All right, so let's take a look at different values of L and see what that means for the orbitals. Remember, L can equal 0. If we'll say if n equals 4, L can equal 0, L can equal 1, L can equal 2, and then L can equal 3, right? And so we want to kind of think about what the different meanings here are. M sub L goes from negative L to 0 to positive L, so here it can only be 0. Here, M sub L can be negative 1, 0, or 1. Here, M sub L can be negative 2, negative 1, 0, 1, or 2. And then here, M sub L can be negative 3, negative 2, negative 1, 0, 1, 2, or 3. And then we can draw kind of a little picture over here. And then think about what we have here. So for L equaling 0, M sub L can only equal 0. So we only have one orbital, and it's an s orbital. So we know we have 1 because M sub L only has one value. We know it's an s orbital because s corresponds to L equals 0. That's the letter designation. And s orbitals are just spheres, right? So just a sphere. And if you're talking about a 1s orbital, it's one sphere. If it's a 2s, it's kind of, two spheres in one another, 3s, 3 spheres, that kind of thing. Let's take a look at next. Here we see that we have 1, 2, 3 orbitals. 3 orbitals. And these are p orbitals because when L is equal to 1, we have a p orbital. So you have 3 p orbitals. And so what that looks like, if you think back to earlier, the p orbitals are basically just dumbbells. And so there's one along this axis, one along that axis, and then one along this axis. Next up, we have L equaling 2. When L is equal to 2, we have d orbitals. D orbitals. And think about how many d orbitals are we going to have? Well, M sub L can be 1, 2, 3, 4, 5 different numbers. So you have 5 d orbitals. And so these d orbitals basically just look like a 4-leaf clover. There's 4 lobes essentially. And then, so there's this one, and then plus 3 other orientations, similar to the p orbitals, how they're in different orientations. And then you have one extra one that looks kind of something like this. And then finally, we have L is equal to 3. When L is equal to 3, we have an f orbital. Oops, 5 because there's 5 here. F orbital, right, because L is equal to 3. And then we have 1, 2, 3, 4, 5, 6, 7 of them. So we have 7 f orbitals. And so basically what here we're going to just say is that these kinds of they have approximately 8 lobes. It's essentially just 2 d orbitals. It kind of looks like 2 d orbitals combined. I won't ever ask you to draw that. I'll only ask you to draw s, p, or d orbitals, and I don't care about all the orientations and whatnot. I just want you to know the s orbital looks like a sphere. The p orbitals look like dumbbells. The d orbitals look like 4-leaf clover and then like a dumbbell with a Saturn ring on it. And then f orbitals are just kind of 8-lobed guys. So let's take a look at a nice picture of this. You can see all of your orbitals right here. So this right here is your s orbital. Here are your 3p orbitals. Here are your d orbitals. So you can see they're kind of the 4-leaf clover-esque. And then you've got the one in the middle with this kind of Saturn ring thing here. And then you've got 7 f orbitals. And you can see kind of this one's a good picture. It just looks like 2 d orbitals. But you can see they get a little funky and whatnot. I won't ever ask you to draw f orbitals. I might just ask you to draw s, p, or d orbitals. And if you're wondering why some of these are blue, some of these are red, basically this color represents the phase of the wave. So if you think about a wave, there's this kind of up part and this down part. That's kind of what's represented here, is that this up part is kind of in red, and then the down part is kind of in this blue. Should have picked actually red, not orange. Right. Don't worry about that too much. You don't really have to know too much about them. But what you really kind of want to know is what the orbitals look like. And there's only ever one s orbital, only 1 3 or 3p orbitals, 5d orbitals, and 7 f orbitals.